Due to popular demand, I've decided to create a new video on the where you at progress check. The students in my class asked me for some common problems that they might see in evaluations regarding the unit of analytic geometry. The first problem that we're going to take a look at together is one where we have to find the length of the line segment AB with given coordinates. The first thing that I want you to always do is to sketch whatever the problem is asking you to find in analytic geometry. If it's a line segment, you draw a line. And we apply the formula of the length of the line, which is square root of delta x squared plus delta y squared. And using the given points A and B, we can substitute them in the formula, where in my case, point B was 0.2 and point A was 0.1. And we notice that the length of AB is 10 units. You'll notice this video will be faster than a teaching video because we're just trying to verify that we can apply basic concepts. The midpoint of a line segment we define as the average of the x coordinates and the average of the y coordinates. So the x coordinate of the midpoint is x1 plus x2 over 2, and the y coordinate of the midpoint is y1 plus y2 over 2. Again, please substitute the values of x1 and x2, and we should arrive to the same conclusion that the midpoint has the coordinates 4 and negative 2. I'm hoping that you're getting the same results that I am. We're going to move on to the second problem in this progress check, which is the equation of a circle given a certain radius. In our case, the equation of a circle is r squared equals x squared plus y squared. Since the radius is given to us, all we have to do is substitute r with 15. So 15 squared equals x squared plus y squared. 15 squared is 225. And we state the final equation of the circle as 225 equals x squared plus y squared. The next problem still involves the circle, but now we have to verify that a given point lies inside or outside a circle. Now, if we think about it, inside the circle, it means that the radius that's formed between the center and the point is less than our given radius, or bigger if it's outside. First of all, let's see if it verifies the equation given to us, which is x squared plus y squared equals 36. We verify by substituting the coordinates of the point in the equation of a circle. And we have to see if the new x and the y verify that equation. Well, we notice that once we substitute, we get 34, which does not equal 36. Since 34, which is the radius formed by our point, 5 and 3, is less than the radius given by the equation of the circle, it means that the point lies inside the circle. It generates a circle smaller than our own. The next problem deals with verifying quadrilaterals, verifying shapes. Well, the first one we have to verify is a triangle formed by vertices A, B, and C. And when we have to classify triangles, we have to verify them by length. That's the only thing that we know right now. We know that we can have scaling triangles, we can have isosceles triangles, or we can have equilateral triangles. Now, what do we know about these triangles? Well, if they're isosceles or equilateral, certain properties relate to them in terms of the length of a line. So what do we have to do? We have to calculate the length of AB, the length of AC, and the length of BC. Now, the length of a line, as a reminder to you, is square root of x2 minus x1 squared, or delta x squared, plus y2 minus y1 squared. Please remember the tips that I provided you in class and label your points as 0.2 and 0.1 so you can keep yourself on track. Now, AB, I got to be, the length of AB is square root of 17. The length of BC, as a note aside while we're doing the calculation, Nobody's asking us for precise measurements. I just have to prove if two or more sides are the same. So I just want to see if the square roots are the same. So BC I get as being square root of 34, I believe. And for AC, once we substitute points A and C inside the square root, we get to be square root of 17. Again, please verify your dimensions at home. Now, since two of the sides are the same, it means that our triangle is isosceles in nature. So two of the sides are the same, AB and AC. The next problem that we're looking at is classifying a quadrilateral, sorry about that, formed by the vertices A, B, C, and D. I always start by finding out what the slopes of each side are. Why? Because I want to see what the slopes are telling me about a certain quadrilateral. Do I have slopes that are the same? Do I have slopes that are negative reciprocal? And it really helps us in narrowing down what type of quadrilaterals we'll have. Now, the slope is rise over run, or delta y over delta x. So I start with the slope of AB, which is 1. The slope of BC, again, delta y over delta x between B and C, which is negative 1 over 2. The next one is the slope of CD, which is 1. And the slope of AD between points A and D, which is, through calculating, negative 1 over 2. Now, what do we notice? We have two sets of lines that have the same slopes. What lines have the same slopes? Where they are parallel lines. Also, in the process of developing this conclusion, we notice that we have no negative reciprocal slopes. So no two adjacent sides are perpendicular to each other. What does that mean? If I have two sets of parallel lines and no negative reciprocal slopes, we can narrow it down to two shapes, either a parallelogram or a rhombus. Now, a rhombus is different than a parallelogram because it has all four equal sides. Now we have to decide which one we have between the parallelogram and the rhombus. And for that, we have to calculate the length of all four sides, AB, BC, and CD. Now, the length of AB, once we apply the length of a line formula, is square root of 8. The length of CD is square root of, now 7 minus 5 is 2, squared is 4. 1 minus negative 1 is 2, squared is 4. So again, it's square root of 8. So far, I can see that opposite sides do have the same length. Let's see what about BC and AD. For AD, the length of the line is square root of 16 plus 4, which is square root of 20. And for BC, we are going to notice that the length is also square root of 20, which means that since we have two sets of parallel sides and two sets of equal sides, our quadrilateral is a parallelogram, not a rhombus. The next problem is a bit more complex because we have three major lines that we have to find in this particular triangle. The first one is the equation of the median. Now, the median intersects AB at the midpoint. D is the midpoint of AB. How do we calculate the midpoint? The average of the x coordinates and the average of the y coordinates. Once we know the midpoint of the line, which is 2 and 2, and we have the other originating point of the median, which is 5 and negative 1, we can calculate the slope of the line. Please remember, whenever we are asked to find the equation of the median, the equation of an altitude, we are looking for the equation of the line. We need slope. Now, we can construct the equation of the median by using the equation of the line in point slope form. Y minus y1 equals m times x minus x1. And by substituting one of the points in the equation. Now I'm choosing D because it has no negatives, so y minus 2 equals negative times x minus 2. Please distribute the negative sign and rearrange the equation. The equation of the median is y equals negative x plus 4. the second important equation of a line that we have to find is the equation of the altitude for side BC. What does that mean? Is that the line that we originate at vertex A is perpendicular on side BC. Now, perpendicular lines have a very important property. They have negative reciprocal slopes, and that is very useful when it comes to calculating the equation of the altitude. Since AE, which is our altitude, is perpendicular on BC, that means that they have negative reciprocal slopes. So as long as I can find out what the slope of BC is, I can find the equation of the altitude. Now, applying delta y over delta x, I notice that I calculate that the slope of BC is -2, which means that the slope of the altitude, which is AE, is the negative reciprocal of -2, or 1/2. Now, going back to the equation of a line and using the originating vertex A, I'm going to construct the equation of the altitude as y minus 1 equals 1/2 times x minus 1. Y equals 1/2x. Now, -1/2 plus 1 gives us positive 1/2, and that is the equation of the altitude. The third important line in a triangle is the equation of a right bisector. Now, a right bisector has two important properties. It divides the intersecting line into two equal halves and it's perpendicular on it. What does that mean? It means that GF, which is our perpendicular bisector, is perpendicular on AC, or the base of the triangle, and also F is the midpoint of side AC. And remember, if we can have at least one point and the slope of the line, we can construct the equation of any line. Well, first we're going to get the midpoint, F, because it's the midpoint of AC, and we can calculate what the coordinates of the point are, which are 3 and 0. And then we can calculate the slope of GF by calculating the slope of AC. Now, the slope of AC is -1/2, which means the slope of GF will be +2, because they are perpendicular lines and they have negative reciprocal slopes. Again, we are going to use the equation of the line in point slope form and sub in point F with coordinates 3 and 0 and the slope of 2. Distribute the slope and rearrange the equation, and we find the equation of the right bisector. We're almost towards the end. We are looking at the last problem. It's coordinate geometry. We are asked to find the distance between the store and home. Now, we are told that the store is halfway between home and school. So as long as we can find the length of the line between the store and the school, we can double it and find the length from school to home. So the distance from store to school is square root of 6 squared plus 2 squared, or square root of 40. Now, when we double this distance to find the distance all the way home, it is 2 square root of 40, because square root of 40 plus square root of 40 is 2 square root of 40, or using a calculator, we notice it's approximately 12.7, let's say, kilometers in length. For the second one, we are asked to find out what the coordinates of the home point are. Now, we know that x, which is the x-coordinate of the midpoint, is x1 plus x2 over 2. And by substituting the known coordinates, we can isolate for x2 and solve for it. Please use cross multiplication, as it's going to be most likely the most efficient and the fastest. For y, also we know that the y coordinate of the midpoint is y1 plus y2 over 2. Again, we solve for y2 and we notice y2 equals -4. So the coordinates of the home point are -3 and -4. Now for C, we are asked to find which friend lives closer, Tommy or Irene. Now, both for Tommy and Irene, we are given coordinates, so we have to find the length of the line from home to Tommy and from home to Irene, and state which one is closer to the home point. Substitute the known coordinates of home and Tommy in the length of the line for home to Tommy, and repeat the process for home to Irene, and we notice that Irene lives closer to the home point than Tommy, since the length of the line formula generated a smaller number. The last problem, number 8, is calculating the distance from the point 2 and -1 to a given line 2y plus x equals 10. Now we know that the shortest distance is a line perpendicular on the given line, or a line segment. What does it mean to calculate the shortest distance? It means we have to find the length of line segment PQ. We do not know what it is, but we do know one very important thing, is that PQ is perpendicular on the given line. So if we rearrange the given line in y equals mx plus b form, we can find the slope of PQ. Since the given line has a slope of -1/2, PQ will have a slope of 2. Now, since we know the slope of PQ and the originating point P, we can use the equation of a line in slope point form and find the equation of line segment PQ. So y plus 1 equals 2 times x minus 2. Sorry for the mistake. And we rearrange y equals 2x minus 2 times -2 is -4, minus 1 is -5. Now we have two equations, the given line and the equation of PQ, and we have to find a point of intersection between two lines. We can form a systems of equation, and by using elimination, which I'm going to recommend you using more and more from now on, you can find the point of intersection. We're going to eliminate the y's, and 2x minus -x/2 becomes plus x/2, -5 minus 5. We're going to isolate the x's, so 2x plus x/2 is 5x/2 equals -10, equals +10, sorry, or 5x equals 20, which means that x equals 4. Now we can use the value x equals 4 and substitute it in one of the two equations. I'm going to choose the 2x minus 5 equation. So 2 times 4 minus 5, y equals 3. What does that mean? Is that the point Q, which is the point of intersection, has coordinates 4 and 3. Now we can calculate the length of PQ between P and Q by doing delta x squared plus delta y squared, or square root of 20 units. Hope I didn't go too fast. Again, it's a review for your final preparation for the unit test. Good luck!